Again, this is obviously one of the constructed responses released in 2019 for practice. This one is about the wavelengths, and it concerns various topics. And before I start going through this, just remember that ideally you should be trying these first on your own and completing these if possible without going to this video. So this video is used in case you want to check your answers that you got, or if you do end up getting stuck or stumped, or you're really not sure about your answer that you have, you can kind of reference this video. I mean, you should always reference it at the very least to check your answers. Like, even if you're pretty confident that you're correct, you probably should see what I got or what I did. Anyway, so this one starts off by listing 6 wavelengths. In a science experiment, a scientist records the wavelengths of 6 waves. 1, 2, 3, 4, 5, 6. The wavelengths in nanometers are listed below. Now, it does occur to me that this type of unit might end up being important. It's not exactly common that the particular units involved end up being super important. It can definitely happen. And here, I don't believe the fact that we're using nanometers will matter at all. But it's always good to notice what units we're talking about, because they might really play an active role in your final answers or the work you do and stuff like that. So obviously by now you've noticed that these 6 wavelengths are given in different forms. This one's just a decimal, this one's a fraction, this one is a base to a power, another sort of decimal type number, another fraction, and then a number that's technically in scientific notation. So cutting to the chase here, my advice when it comes to problems like this where you have to compare certain numbers to other numbers so that you can put them in order from least to greatest, or a question like this where they're asking which 2 wavelengths are actually equal to one another, you want to pretty much change them all to decimals. Again, my advice is that it's always easiest to compare numbers to each other when they are in decimals. Anyway. So this one's already a decimal, so that one's good to go. Fractions, okay? You literally need to remember that fractions are just division problems. So 5 over 100 literally means 5 divided by 100. And so you can just go to your calculator, and I'm using this one, and do 5 divided by 100 and get 0.05. I just want you to be aware of something, gang, that if you were using, say, this particular Mamma Jamma calculator, and you enter this as a fraction, I just want you to understand that if you use this n over d button, first of all, you can't really use this n over d button unless you're in a particular mode. And that mode is math print. So you have to be in math print mode just to use this button, this n over d button in the first place, the way you probably expect it's going to be used. And then if you do 5 over 100, guess what? It's not even going to give you a decimal most of the time. It's going to give you a reduced fraction. Now this can be totally useful in other situations, but here we want a decimal because we wanted to compare it to the other ones. So I have no use for math print mode in this particular situation. I want to keep it in classic mode, and that's where I got the 0.05. This one likewise, I mean, maybe you know what a negative, I mean, hopefully you should know what a negative exponent is all about, how this could be rewritten as 1 over 10 to the third power. But considering the situation here, why not just go to our calculator? And I'm going to use the caret button, which means to raise to a power. And then I got to type in -3. Please, please, please remember that there's a negative button and there's a subtraction button. Here I need to type in -3. So I got to use the negative button. And that's going to get me 0.001. And then this one was already a decimal. So that was sort of good to go. This one I just literally divided again. 1 divided by 1,000. And then this one, you know, if you understand scientific notation, all the better for you. Because this -2 power means we take the decimal point, which is at the start, it's there. And we would move it 2 places to the left. And then we would end up with like 1 placeholder 0. You know what I mean? Or you could just literally go on your calculator and do 2 times 10 to the -2 power and get 0.02. Anyway, I'm sure we are in... Get out of there. Now, I started to write down, you know, what this actually means in decimal form, but I'm sure what they want here is, you know, the 10 to the how they originally represented it. So the equal wavelengths turn out to be the 10 to the -3rd power and the 1 over 1,000 are the equal wavelengths. Yeah, that seems right. All right. Which wavelength is the shortest? Which wavelength is the shortest? Well, that looks like a pretty good contender. Let's see here, though. 0.0001. I mean, again, hopefully you understand how decimals work. 0.05. You know, remember, this is really 0.05, you know, 00. And that's really, you know, in a way, 0.0010. I don't know if you absolutely need to be doing what I'm doing right now and adding these zeros. 1.0, that's obviously bigger. 0.0, okay, and then 0.02. So again, like, it looks like this one is the shortest one, and if you don't understand why, then please let me know or ask me or ask somebody about that. But it looks like the shortest wavelength, the smallest wavelength, is 0.0001. And then moving on to part C and part D on the other side. Please refer to previous. Okay. To find the speed, okay, looks like we're changing gears here a little bit. To find the speed of a wave, the scientist uses the formula shown below. So speed is going to be equal to the wavelength times frequency. Okay. The wave with wavelength 10 to the -3rd power nanometer has a frequency of 10 to the x. Okay. Wavelength, frequency. The speed of the wave is 10 to the y, where y is greater than 3. Write an inequality in terms of x to represent all possible values of x. Okay, look, once again, you should have already tried this by the time you're looking at this video. And so, look, so you should understand when I say that, you know, reading this for the first time, and again, this shouldn't be the first time you're reading this, this can be intimidating. Okay, I get it. You know, you might have to, like, take a breath, read it again, not immediately give up, because again, like this is, intimidating at first. Okay, like we got this x variable and then 10 to the x and 10 to the y, and we were in inequality and all this like speed and wavelength and frequency, all a little intimidating at first, a little bit hard to organize your thoughts and a plan and keep trying to wrap your brain around this thing in its entirety. But look, just don't give up. Speed equals wavelength times frequency, okay? Literally a formula. And they say, okay, here's the wavelength, here's the frequency, and the speed of the wave is 10 to the something. So I mean, look, let's write it down, okay? So the speed is 10 to the y, and that's going to equal the wavelength, which is 10 to the negative 3, times the frequency, which is 10 to the x. So hopefully when you write this down, and now you look at this right side, do you see any math to do, right? 10 to the negative third times 10 to the x. Don't you add exponents in this situation? So we have like negative 3 plus x. Okay? So 10 to the y is going to be equal to 10 to the negative 3 plus x power. So that means y is basically the same as negative 3 plus x. And now they just want me to have to write an inequality because y can be anything greater than 3. Right? So that in turn is going to be able to have us write an inequality where, okay, so if y is greater than 3, that means negative 3 plus x, which is basically the same thing, has to be greater than 3. Well, look at that. That is an inequality in terms of x. It's an inequality that involves x, basically. In terms of x just means like you're using x in the inequality. You know what I mean? And so, look, I would, optimistically assume that this as a final answer would be acceptable. Because this is literally an inequality that involves x. So again, I would imagine if you just made this your final answer, that whoever's grading your work would accept it. But I don't know. I mean, just because I'm going to actually solve this for x and come up with, I guess, x has to be greater than 6. Which that makes sense, right? If y, so you think back to like this line right here. So if y, if this formula was true, that 10 to the y, that the speed is going to equal the wavelength times the frequency, and if y was going to have to be greater than 3, wouldn't x have to be greater than 6? So there it is. There's my final answer, an inequality that is in terms of x. Okay, part D. The wavelength of a 7th wave is recorded. Okay. This wavelength is greater than that, but it's less than that. Write a possible wavelength in nanometers. Okay. So that's good. Again, the units, they want you to keep the same units, which is very good news. That means I can sort of ignore the units. For the 7th wavelength, write the possible wavelength as a fraction with a denominator of 100. So first of all, I have to come up with a wavelength that's in between this and this. But they want it written in a very specific way. Okay, so 2 times 10 to the negative 2, wasn't this 0.02 5 divided, wasn't that 0.05? I think that was 0.05, but let's double check. 5 divided by 100, 0.05. And again, I don't know, technically I should probably also include zeros there, whatever. So first of all, right, something that's in between. I mean, look, there are more than one correct answer. Let's just put it that way. Because I could talk about 0.02. Well, let's just keep it simple. So you could I'm sure what most people are going to pick is either 0.03 or 0.04. I'm just going to go with 0.03. So that is my possible wavelength. But you're not allowed to give your final answer like that. It's got to be as a fraction with a denominator over. Okay, well, if this 5 over 100 is 0.05, then I assume that 3 over 100 is that. But let's just double check. 3 divided by 100. There we go, baby. So my final answer is going to be 3 over 100. That's my answer, because they wanted it written as a fraction with 100 as a denominator. Now, I imagine like this is going to be a very, very common correct answer, and I imagine another one would have been 4 over 100, because what this really means is 2 over 100. You know what I'm saying? But I believe these would be the two most common answers. And that does it for this constructed response.